This video is for section 6-5, quadratic functions and word problems. In this video, we'll work some examples together. A stone dropped from the rim of a moon crater will fall 21.6 feet in 2 seconds. So we have a distance and we have a time. If the distance traveled in free fall on the moon is directly proportional to the square of the time of fall, find how far the stone falls in 5 seconds. We have a directly proportional situation, and we're comparing distance to the square of time. We've practiced 2 ways of doing the problem. One way is to use a model, and the other way is to use a proportion. I'm going to choose the proportion technique. From the first sentence, we know that a distance of 21.6 feet can be paired with a time of 2 seconds. So 2 squared. And then that's equal to another distance and another time squared. The last sentence of the question asks us how far it falls. So we don't know the distance. Use a variable such as d, and the time is 5 seconds. So 5 squared. Solve this using cross multiply. 2 squared times d can be written as 4d. The other diagonal is 21.6 times 5 squared, which is 25. Divide both sides by 4 to get the letter d alone. And the answer is 135. And the distance is being measured in feet. So in 5 seconds, an object would fall 135 feet on the moon. Here's another example problem. The crushing load of a circular pillar with a 10-inch diameter is 200 tons. A pillar is a vertical column that supports a weight. What this is telling us is if a pillar is 10 inches wide, it can support a weight of 200 tons before it crushes. Find the crushing load of a pillar that's the same height and material, but with a diameter of 14 inches. So a wider pillar. If the crushing load is directly proportional to the 4th power of the diameter, we have a directly proportional situation. One of our variables is referred to as the crushing load, and it's directly proportional to the 4th power of the diameter. So if we use proportions again, this would be the arrangement of our ratios. From the first sentence, we know that a crushing load of 200 tons goes with a diameter of 10 inches. Then say equals and create another ratio. It asks us to find the crushing load if the diameter is 14. We can solve this using cross multiply. 10 to the 4th power times c is equal to 200 times 14 to the 4th power. To get the letter c alone, divide by the 10 to the 4th power. And the result is about 768. The crushing load is measured in tons. So this circular column with diameter 14 inches can support a weight of 768 tons before it crushes. One more example. The power expended by heat in an electric circuit of fixed resistance is directly proportional to the square of the current. If a circuit expends 180 watts of power when a current of 6 amps is flowing, what is the heat expended when the current is 10 amps? The variables that are directly proportional were called the power expended by heat and the square of the current. So this pattern gives us our ratios. One of the sentences said we have 180 watts of heat when the current is 6 amps. Then say equal and create another ratio. It asks us what is the heat when the current is 10 amps. We can solve this using cross multiply. 6 squared is 36 times the p. And the other diagonal is 180 times 10 squared, which is 100. Divide by 36 to get P alone, and the result is 500. In this problem, power expended by heat was measured in watts. This electric circuit with a current of 10 amps will lose as heat 500 watts of power. Let's summarize the lesson. We worked a few example problems, all involving direct variation. To solve these problems, identify the two variables so that you can create ratios, one number on top, the other number on the bottom.